this is a quick demo of what I have done today. Basically, I have tried to interface lot many components. Like instead of doing it on an individual thing, I have tried to interface, like try to interlink a lot of components here. So I have in the circuitry, I have a buzzer over here. I have an LCD display, the standard 162A. Here I have hooked up the LCD. I have soldered the pins quite nicely and hooked up to the birch strip over here. And there's quite a lot of mess over here, but everything is functional, so yay. Over here, this is the temperature sensor LM35 from Texas Instruments. Then we have, just besides that, is a pot, a smaller one, where you have to adjust the value by using a screwdriver. So that pot is basically to control the contrast of the LCD. And then next we have here is an LDR with some small resistance, and here we have the two servo motors here. This is servo number 1 and this is servo number 3, and here I have tried to do some jugaad, which I'll explain later on, and you might be wondering what a t-shirt is doing there, so let me explain. So this basically is, let me show you the program. So this basically, okay, so fine, I'll explain what this is basic. The thing is, I was trying to fold my t-shirts today, all of them, and after some time my back started aching. So I was like, oh, why not assign this task to my Arduino and simplify my work. And then I recalled the t-shirt folding mechanism from the Big Bang Theory, the one where Sheldon uses his plastic thingy, like there are 3 flaps, left wala flap, right flap, and then the base one, which goes like this. So the t-shirt, basically what you do is you put the t-shirt backwards like twice. The first flap does this, you get a very sharp crease over here, and I'm doing it with my one hand. So, and in the second flap gives you this second crease, and the third flap, which is this, gives you the halfway. This is not halfway, but since I had this cardboard, the box, this was the max size that I had at my home, so this can be large. So the third flap will place your fold likewise. It should be like this somewhat. Okay, so here this can be easily done by using 3 servo motors. I've written my code for 3 servo motors, but I have only 2, and as you can see, I've implemented only 1. That's because you can see here what I have done. I don't have the tools to make this very sturdy. I have basically used a female bird strip, which is this, and this is the male bird strip, and this is a cardboard. As you can see, some creases over here. So yeah, and I had this kind of that came with the servo, and I could use only this. I wanted to have bigger one, like this big, like the Lego ones. Like if I had the Lego, then it could have been very easy task for me. I don't have the gears as well, so what I have done, the jugaad, is these are two. I can remove this now since I have given the demo. Here you can detach the servo like this, and as you can see here, these are the two needles that I got, and it's, oh my god, it's good that my demo is over. See, I have broken the bird strip. That's basically because of the pressure. Over here also in the morning I broke this part, and then this was another part that over here the needle should not displace from its place, so I have attached a small wire likewise, and so yeah, this is the thing that I came up with in order to have a sturdy and firm movement. And this is a refill basically of this pen here, and I have pushed it way inside back. That's because to have this aperture fixed over here so that it could rotate on this movement, this axis only. Why I didn't the two needles that I had, they were not able to displace this cardboard, the whole thing. The other part is quite damaged. It literally damaged the cardboard, so I had to disperse the load evenly. So I had this bird strip which helped me, it goes inside like this, and then it could evenly distribute the load and make it easy for moving the cardboard. See, if I had this is the more it gets very hard, and if you keep it likewise, it becomes very easy for the motor to the load gets distributed. So yeah, and this is basically like a factory to me. This is an LDR over here. You can see this LDR is basically like when the lights are switched off. The factory should run 24/7, right? So when it is night time, this LDR senses that it is getting darker, and it sort of makes the LED glow. So when it is night time, the LED should glow. I blew up this LED, so I'm using the onboard pin 13 LED on the Arduino. So yeah, and I'm also displaying the temperature via this LM35 on the LCD as you viewed it in the start. So oh shit, I didn't give you this demo, damn it, but I have already broken this thing. I don't think I am in a position to displace this load, because it gets quite heavy when you have a t-shirt with this big. So what it did is it rotated likewise, only this much. So what it's like, it will throw off this edge likewise. So yeah, it doesn't get it does not form the right crease likewise, but good enough for a proof of concept thingy. So yeah, I was going to explain the code right here. So what I have done here basically is the servo library, the LCD library, then the LCD pins that I have used on the PWM. These are the 3 servo objects that I have created. The next one is for the servo position, and this flag is an integer which I have used for defining the motors, like which motor is running right now. So if it is 0, then the motor 1 is running, servo motor 1 is running. If it is 1, then servo motor 2 runs. If it is 2, servo motor 3 runs. So I'd use this code. I've used this flag integer in the first, but it's still there. I found it very useful. And the buzzer, then this is for the temperature, and this is for the LED pin 13, which we are using for the LDR sensor. So, and we are assuming the threshold to be 10. From trial and error method, I found out that on a regular tube light, the LDR senses somewhere around 35 to 40. The value is around 35 to 40. For a flashlight like the phone's flashlight, it's 145, and for pitch dark, it is dark black, it is 4. So I've assumed to be 10 just to be sure, the sensor reading to be 0, and LED state to be default low. This is the wide setup. 3 servo motors, the LCD, then the buzzer pin as the output, the LED pin as the output, and CL.begin. These 3 functions are for the LCD of the nature void. I have called this function in the void main loop. This is for the displaying of which motor is to be running, which motor is currently running now, and is the T-shirt folding done. In the third loop, I have that means when the servo motor 3 is running, this function is called. At that time, the buzzer is also high, as you saw. Next, we have the void loop, the main function. This code is for the LDR. It compares the threshold, and if the value is less than 10, the LED pin 13 glows. Next is the temperature code. We have this calculation over here, and next we have is the flag variable, which I explained before, to set 0, and then likewise is when it is flag 1, motor 2 runs, when it is flag 2, motor 3 runs. And here setup function, here 1, 2, 3, this basically gives the call to this setup function above here, and it displays on the LCD which motor is running currently. So basically this is what I wanted to do. I wanted to integrate, interlinked each and every component. All this time I used to do only one servo, only LDR circuit, only temperature circuit. Yeah, so I also tried to have this DC motor here. So it's like when the temperature is more than, when say 30 degrees, the motor should motor should run to, in order to cool off the whatever the temperature sensor is sensing. Suppose the motor is running for 24/7, and it is bound to get heated if it is not cooled properly. So if the temperature senses key, this motor is heating a lot, it should on this additional fans. This motors actually, the 5 volt DC motors, they take up a lot of current, and as you can see, I don't have any external power circuitry. It's running on the 5 volt and ground of the Arduino itself, and it's connected to my laptop. So the current rating is bound to get, the supply is bound to get very low, and you could have seen the LCD fluctuating when the motors were running. So, and sorry about the mess part that I have done over here, but this is one of the I wanted to do this part, but it seems it is very hard for me to, I don't have the right tools. As you can see here, I have used needles, and I've also broke this bird strip. So, but it was awesome. I really miss, I should get those Lego blocks where you can easily turn. That's where that is why I love Lego. It's the all the mechanical parts gets easy for you. And thank you for watching. And I'm Sarvesh Pimparkar signing off. Peace.